sorry, I'm unable to
allow me.
understand this.
Okay. Here we go. So we are doing some solving again today. Again, using your quadratic, not quadratic, your unit circle will be useful again for you.
More units.
It won't end. So having that unit circle handy again will be helpful, but also just knowing it. So we are solving trig equations using factoring. So just like we know if we have x squared plus 5x plus 6 equals 0, we have a quadratic. All right, and if we have a quadratic, then we can double bubble to solve. What times what is x squared? And what times what is positive 6? Ooh, see. 5 and 1 is 5. 3 and 2. 3 times 2 gives me the 6, and 3 plus 2 make my 5 there in the middle. And then, of course, we can solve and get -3 and -2 for our solutions for x. That's what we're doing, except the x is now replaced with a trig function. Okay? So we are factoring to solve, and maybe it's double bubble like this. Maybe there's a GCF. But those are all the things we want to keep in mind today while we're doing these. So here we go. We want to solve the following equations for values between 0 and 2 pi. So that's just one rotation around our unit circle. And you can see here, this is a quadratic form. We have something squared plus a something and then minus or plus a constant. This is going to double bubble for us. So first times first has to be 2 cosine squared. What times what is 2 cosine squared? Almost. 2 cosine theta times cosine theta. Cosine times cosine is cosine squared. 2 times 1 is 2. All right, and then last times last has to be a -3. What times what is -3? -1 times 3 or -3 times 1. Those are our only options. So I'm going to go ahead and plug those in there. If I put my -3 on the outside here and a +1, look what happens. We got to check the... Yeah, this, when we check the outer and inner products, here we would have -6 cosine theta and a 1 cosine theta. That gives me -5. So that one didn't work. So I want to swap. I don't want the 3 on the outside. I want the 3 on the inside. So I want a +3 and a -1. Now when we check, I have a -2 cosine of theta and a +3 cosine of theta. And when we combine those, that gets me my middle term. All right, so then what do we do after we have our bubbles? Yeah. So set each bubble equal +3 equal to 0. So cosine theta -1 equals 0. We set each bubble equal to 0 and solve. So how do I get the cosine theta by itself? -3 and then divide by 2. So cosine of theta equals -3 over 2. Over here, I'm just going to move the 1 over, so I'd get cosine of theta equals +1. For some reason, this seems weird to me, does it? To you? It's kind of like our radical 3 over 2, but it's not the same at all. Tell me what the cosine curve looks like. High, middle, low, middle, high. What is the high point? And what is the low point? -1. This is -3 over 2. Do they ever intersect? No, they do not. This is it's outside our range. Our range goes from -1 to 1. This is what I would call too big, but it's actually too small. 1 is on... No, we're not quite done yet. So we want to go to our unit circle and say, hey, where on the unit circle does cosine have a value of 1? At 0. Yes, that is our ordered pair 1 right there. All right, so it's when theta is equal to 0 radians. Do they want an answer of 2 pi?
Yeah.
Are we allowed to have an answer of 2 pi? No, this says must be less than 2 pi, so 2 pi is not going to be an answer in our Delta Math today. So this is the only answer, 0. Period. Okay. Letter B here, we have 3 cosecant squared plus 6 cosecant theta equals 0. What do you notice about these?
3 cosecant.
GCF, greatest common factor, what can we take out? 3 cosecant theta. If I take out the 3 cosecant theta from each of these, what's left behind? Plus 2. Third time's a charm. Okay. All right. So, how do we know we did that right? Distribute it back. Yeah, we could distribute it if we want to. 3 cosecant times 2 would give us 6 cosecant theta. So, we did that right. And now again, we just set each thing equal to 0. Set each bubble equal to 0. So I'm setting each thing equal to 0, and let's see, I want to go ahead and get cosecant by itself, so what should I do? Divide by 3, that doesn't do much for me. 0 divided by 3 is still 0. Here I'm going to move the 2 over, so that's going to be cosecant theta equals -2. But I don't like cosecant so much, what should I do? Flip them. Flip them. The reciprocal of both of these. What is the reciprocal of cosecant? Sine. All right, and if you flip 0, what do you get? 1 over 0, which is undefined. Okay. Can I get any answers from that? No, that's no good for me. Okay. Over here, if I get sine of theta and I flip my -2, what do I get? -1/2. Yep. Okay. So I don't need to worry about this one because it's undefined. Over here, I'm going to go to my unit circle and say, hey, on my unit circle, where are the sine values equal to -1/2? Good, yeah, those are the little short sine 6 right there. So 7 pi over 6 and 11 pi over 6. Very good. Okay. Questions on these so far? Very good. All right, let's look at C and D, and then we're done. What do you want to do for C? Okay, we could do a GCF here. Sure, that'll work. We could take out a 3, and if I take out a 3, what's left behind? Tangent squared theta -1. Good. And how do we know we did that right? Multiply it back in, distribute it back in. Now we are undistributing, that's all we're doing. Okay, so this is pretty interesting. Okay, well, I like this. I wouldn't have done it this way, but yeah, we can. So you want to set it equal to 0? We can do that. So does 3 equal 0? 3, it does not. So we ignore that, as that's not ever. You could double bubble this. It is difference of squares, but we can just solve it because it's a square root method. We could just say, hey, tangent squared theta -1 is equal to 0, and then I'm going to go ahead and add my 1. And then how do I get tangent by itself? How do I get rid of square? Square root. square root. Don't forget the plus or minus. So the square root and the square cancel out. So we get tangent of theta equals plus or minus 1.
Wouldn't it be plus or minus tangent also?
They sort of, usually, but so we don't do plus or minus on both sides because they sort of negate one another while still we only need one of them, one of those plus or minuses. So yes, we do there is an invisible plus or minus here, but it turns out that it just creates extra work that is unnecessary. So one is enough in that case. And so here, we want all the places on the unit circle where tangent has a value of positive or negative 1. Where does that happen? All the over 4s, yeah. So tangent is the y over x coordinate, sine over cosine, and all the 4s. So 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So all the over 4s are where tangent is equal to 1. All the isosceles triangles. All right. So that was this one. Technically, we could have used the square root method from the beginning. We could have just added the 3 divided by 3, and then we'd get the same result. But so square root method. That's why I did it that way. That was the goal of that one. And this one we have 1, 2, 3 terms. What do you want to do first? Pull out a 3. If I take out a 3, what's left behind?
Secant squared theta plus 2 secant squared theta plus 1.
Okay. And now this has 3 terms, which is, how do we deal with that? Double bubble. Okay. So we're going to double bubble. What times what gives me secant squared? Secant times secant. So secant theta times secant theta. And last times last has to give me a positive 1. What times what gives me positive 1? Positive 1 times positive 1 gives me a positive 1. How do I know if I did that right? Do the little smile, check the grin. Yeah, so on the outside we have secant of theta times 1, and then just secant of theta. Secant and secant give me 2. So we got our middle term. We did it right. Okie dokie. And then what do we need to do? Set it equal to 0. Do I care about the 3? No. So we set each bubble secant of theta plus 1 equal to 0. Oh, hey, do I need to do it twice? Okay, that's sort of superfluous. That's a good word.
No idea what that
Superfluous? Totally unnecessary. Over the top. All right, and then we would need to do what? Minus 1. So secant of theta equals negative 1. And I don't like secant, so I'm going to flip it. Do the reciprocal of both sides. What is the reciprocal of secant? Cosine. And if you have a negative 1, and it's negative 1 over 1, and you take the reciprocal of that, what do you get? Still negative 1. All right, so now this is asking, hey, on our unit circle, where does cosine have a value of negative 1? Pi, right there, theta equals pi. So you're factoring. Nope. Nope. It's good. Okie dokie. Medultimus. 14 minutes. That's great. That's a